Good morning, children. I hope you are all good. In previous class, we studied about the physical properties of the metal. What are they? Malleability, luster, and metals are hard. And malleability, ductility, and metals having high melting point and high boiling point, and they conduct heat and electricity, and metals give sonorous sounds. These are all the physical properties of the metal. So in previous class we compared some of the non-metal is compared with metal. In previous class some of the non-metal with metal. Some of the non-metal is compared with metal. We already discussed in previous classes. So some of the examples of non-metals are sodium, iodine, hydrogen, oxygen, etc. These are the examples of non-metal. So now we discussed about non-metal. The metals or non-metals are some are solid or some are gaseous. Some are solid. So some are solids or some are gaseous, except bromine, which is liquid. Some are solid or some are liquid, but except bromine is a liquid state. So, non-metals have a physical property similar to the metals. Non-metals kuda physical properties that are equally similar to the metals. So, we concluded that we cannot classify the element either a metal or a non-metal by the physical properties. We cannot classify the elements either a metals or non-metals by the physical property. We cannot judge approximately. We judge either it is a metal or non-metal on the basis of physical properties. Wow, what are the examples of that? That is, we know that all metals are solid at room temperature. Is it right? All metals are solid at room temperature, except mercury is a liquid at room temperature. All metals are solid at room temperature, except mercury is a liquid at room temperature. And another one is the metals have high melting point. Is it right? The metals have high melting point. But some of the metals, that is gallium and caesium, they have low melting point. These two metals are melt if you kept in your palm because they have low melting point. These are two metals, but they have low melting point. These two metals are melt if they are kept in your palm. And iodine is a non-metal, but they have a metallic luster. So iodine surface is very shiny. So they have metallic luster. And carbon is a non-metal. They are existing in different forms. You already studied We call it as allotropy. Allotropy, carbon is a non-metal that exists in different forms. That forms we call it as allotropy. In that, diamond is an allotropy form of carbon. Diamond is a allotropy form of, like, it is a non-metal. So, it is a very hardest metal. Non-metal, very hardest non-metal. So, diamond is very hardest non-metal and they have high melting point and boiling point. They have high melting point and boiling point. And next is graphite. Graphite is a one kind of the non-metal. Graphite is a another kind of the non-metal. So that graphite also conduct electricity. That graphite conduct electricity. Did you got it? Some of the non-metal physical property is similar to the metal. Some of the non-metal physical properties is similar to that of metals. Next is the alkyl metals, that is potassium, sodium or lithium. These metals are very soft. These metals are very soft metal. It can be cut by using a sharp knife. These are all very soft. It can be cut by using sharp knife because of they have low density. Because they have low density and low melting point. Low melting point. Clear about it? This is the similar properties to the metals and non-metals. That's why we cannot judge the elements, it is a metal or non-metal on the basis of physical property. How we classify the metals? Yes, we classify perfectly through the chemical properties. We can judge or classify through the chemical properties. Yaudru mukhantra navu adanna classify madakagute. It is a metal or it is a non-metal anta. On the basis of chemical properties. Clear about it? We cannot classify the element. It is a metal or non-metal by the on the basis of physical properties, but we can classify the elements, metals and non-metals, on the basis of chemical properties. Shall we move on next? Yes. Next is, I tell you one of the experiments. Let's think about it. Take a magnesium ribbon and a sulfur powder. Take a magnesium ribbon and sulfur powder separately. First, burns the magnesium ribbon. And collect the ash forms and after the ash to dissolve it and dissolve the ash in the water. Dissolve the ash in the water and test the solution by using a blue litmus or red litmus paper. What you observe, sometimes metals gives rise to, magnesium ribbon is a metal. Metals gives rise to basic oxides. Basic oxides when they are dissolved in water. Sometimes metallic oxide metals gives rise to basic oxide that dissolved in water. And next time, sulfur powder. Take a sulfur powder in a test tube and burns the test tube and hold another test tube to the mouth of the first test tube. Here the fumes are formed. The fumes are collected to the upper side of the test tube. And close the mouth of the test tube by using another test tube. The fumes are collected to the upper side of the test tube. Add the water to this test tube and shake properly and test the solution by using red litmus and blue litmus paper. What do you observe? Sometimes non-metals gives rise to acidic oxides. Acidic oxides when they are dissolved in water. Clear about it? Sometimes metals gives rise to basic oxides that dissolved in water, and sometimes non-metals gives rise to acidic oxides dissolved in water. Clear about it? Shall we discuss about this topic in detail in next class?